Welcome, everyone, to another episode of Build Hour. We're so glad you could join us today. My name's Pranav Deshpande. I'm on the product marketing team here at OpenAI, and today I'm joined by my friend Anoop, who's on our solutions architecture team. We're really excited to go deep into the world of distillation here with you today. Just for some context, we launched Distillation in the API platform a little over a month ago at DevDaySF. And it's a suite of tools to make it faster and easier to use the outputs of larger models to improve smaller, faster models on very specific tasks. And so Anoop has some amazing demos for you to cover this and more as we get into the content today. Just a quick recap on the goal of Build Hour. We're here to empower you with the best practices, tools, and AI expertise to scale your company using OpenAI APIs and models. And that's really what we're going to do today with all of the distillation-focused tips and best practices that we have. So just some housekeeping before I hand it off to Anoop. The webinar is going to be recorded. You'll receive a recording at the end of the event later today, maybe tomorrow. There's also a live Q&A. Feel free to drop your questions in the chat. We'll try and get to as many of them as we can, and we'll also answer some of them live. And then finally, the code that Anoop's going to be using for his demo will be shared with you during the course of this event. That way you can follow along and also ask any questions that might come up as you take a look at the code. But with that, Anoop, over to you.
Awesome. Thanks, Pranav. So great. Today we're going to go through a few different parts of the distillation journey. So first we'll go over the main concepts. So you can think of that as like an overview of the distillation platform, why we built it, the motivation, and the problems we're solving for. A bit of a platform walkthrough. And then after that, we'll go into a demo for understanding how, as a lot of folks mentioned to us, they want to use distillation for cheaper, faster, and also keeping the accuracy pretty high for our model. So we'll walk through how to distill outputs from 4.0 and 0.1 into 4.0 mini to achieve that. Next, we'll go through how to use distillation for task-specific models. So say you have a multi-agent system, we're gonna see how we can use distillation to get the same performance in some parts of the multi-agent system. And then finally, we're gonna go forward and see other flows or patterns we can use in the distillation suite, and then future iterations of the platform, along with a customer story. And then finally, the last 10 minutes we'll use for Q&A. So feel free to put in any questions you have into our chat. Cool. So diving right into the concepts. Yeah, so a lot of folks who are using our platform today try to find the equilibrium between cost and performance. So what that usually means is developers are trying to do like many different things to find the balance between cost and performance. So whether that is like prompting, fine-tuning, or using different models at different points of the architecture. And that's a pretty tricky process because one, you don't have all the visibility you need to make the decisions you have to. And also sometimes you might be making trade-offs that aren't worth it. So you might be using much smaller models when you should be using larger ones, or you're just trading a lot of performance away by using like 4.0 mini versus when you should be using 4.0. And with all of these trade-offs, the goal is to make it so you don't have to make these trade-offs. So the distillation platform is the place to give you like the best of both worlds, where you can get the cost to what you need it to be, the latency what you need it to be, while still keeping a high performance bar. So yeah, distillation allows users to improve smaller models with a teacher model. So you can take the performance of 4.0 or 0.1 and teach 4.0 mini to get similar performance. And then with this, users can unlock performance at a fraction of the cost. And the main goal of distillation in our platform is to make it super easy to do all of this in one place, because doing this by yourself is very time-consuming and cumbersome. So we want to make it really easy to save costs and build models that work for your use cases. Great. So to quickly go into some motivation on why we built the distillation product. So one of the first things we saw from customers who were actually trying to fine-tune models and improve models by themselves is it's actually really, really hard to fine tune your own models. One of the main challenges is actually curating a good data set. So there's two ways to curate a good data set. One, you have to manually craft a data set. So imagine spending a lot of human hours creating like hundreds of examples to then have answers for those examples and then finally fine tune it. But you have to have a lot of people to do that. The second way you could do that is you have to log a lot of traffic. You have to make sure the traffic all looks good. Then you have to have some way of evaluating that traffic. And then you have to clean and annotate the data sets to make sure that they're actually curated to be able to be fine-tuned. But now with the distillation suite, you can fine-tune and distill models really easily by curating data sets all in one place and having all of that work, which happens in a totally different systems. So you can have like a logging system, you could have then like an annotation system that maybe is in Google Sheets. All of that we hope to have in one single place for you to get the best performance you need. Another thing that we've heard from developers is as they scale on the platform, latency and price are two characteristics that are increasingly important. We've heard that a lot of as you get like much larger use cases, you become much more price sensitive and latency sensitive, just because costs can balloon if you're using a larger model and putting everything through that workhorse. So it might make sense to use like a 4 mini in that case. And also latency. Not everything needs to take a long time. Maybe you can use fine tuning to decrease the latency as you see fit. So yeah, now with distillation, folks can use smaller models to get the benefits of latency and cost. And then the final one is domain-specific use cases. So most of the time when people are building on our APIs, they aren't optimizing for academic benchmarks like MMLU or the AME exam. What they rather are optimizing for is, hey, does this solve the business need that I'm building today? And how can I make it so it does it as good as possible? So the trifecta of accuracy, cost, and latency. So now with distillation, we hope to make it really easy for you to evaluate your own benchmarks. So the things that you actually care about as a business. And then 2, improve against those benchmarks so you can see improvements across the product you're building. Great. So now just to walk through like the distillation platform and the product suite that we've built to make it super easy to do that. So a quick high level, distillation is the process of like creating smaller and simpler versions of a large complex model while retaining most of the performance. So for like an example that we've touched on a couple of times already is like 4.0 to 4.0 mini. This involves training like a much larger model to replicate the responses, a much smaller model to replicate the responses of a much larger model with samples from production traffic. So the result is a model that operates with lower latency, reduced costs, and making it much more efficient and cost-effective for customer applications. There are 3 capabilities like we want you to know about this product. Like the first is you can store completion inputs and outputs for any logs that you're putting in. Second, you can easily like filter completions to enter into the fine-tuning workflow. So you can typically select a small model to be the student model to fine-tune. And then finally, after fine-tuning is complete, you can easily like filter on those log completions and evaluate the model if you see fit, or you can run evaluations whenever needed to detect regressions or evaluate performance. Great. So just to actually show what this looks like in our platform for these 3 parts of the product. So the first is stored completions. You can see stored completions in the dashboard. And then once you go to the dashboard, on the left-hand pane, you'll see the chat completions product. So the first thing to call out here is chat completions have to be enabled at the org level by an admin. So make sure your admin has enabled that. Then to start logging your production traffic, all you need to do is add the parameter, as you see on the left-hand side of the screen, store equals true, and then your API request will be logged. The other thing to call out here is you can use metadata tagging so that you can track and filter the data as you see fit. And then finally, by default, tracers are stored for 30 days. Cool. So for fine tuning, once you've like already stored all these completions, we can now distill models as you see fit from some of these traces or from data sets that you upload via fine-tuning. So this isn't anything new. The fine-tuning platform has been around for a while, but as we mentioned previously, the ecosystem around fine-tuning has made it much easier to do so. So now you can go from traces to a JSON-L file to fine-tune in seconds versus it usually took much longer to, one, collect the traces, find everything that you need, and then construct a JSON-L file of the right format, and then finally fine-tune. So hopefully now it's super easy to do that. The last part of the product suite are evals. If you haven't already watched the build hours from last week on evals, you should. One of the things that you can do now is you can create evals off of production traffic or uploaded data sets. So from there, you can evaluate against a set of 9 different evaluators, including a custom LLM as a judge evaluator. So there's a few different options you can do for evaluation. And then one thing to mention here is, if you are interested, you can also run all evaluations for free if you choose to share evals. Cool. And then the final thing that just recently launched is it's important to run experiments and tests against the products you're building and the changes you're making in production. So now you can compare evaluations. So maybe you want to test against a different model, a new distilled model against the same evaluation set. You can easily do that and then compare the runs specifically. So yeah, this is really handy when you're making changes to like model parameters as well. Great. So the first demo we'll go through here is talking through how we can build cheaper and faster models while trying to keep accuracy still very high. Before that, we'll actually go through a quick platform walkthrough of how this actually looks in the product. Great. So let's just actually start from scratch and create a simple API request. So let's use 4.0 mini. Looks like cursor is just auto-completing everything for me. So yeah, this is just a simple request that we normally would do. And we just ask, what's the weather in Tokyo? And we get a response back. But to use evaluations, we can store the product and then also add any metadata that we want. So let's just say we want to add the metadata for this as demo and then a noob. This is how we would do that super easily. And then if we go ahead and run this cell, we can then go to the evaluations platform and check how this looks. Before we go there, one thing I did mention previously was this is the place where an org admin would set if folks can use the chat completions product. Now let's go to the dashboard, go to chat completions. We see what the weather is in Tokyo, and then we can see this whole pane. So the first thing to call out here is the chat completions product has a bunch of different filter options. As you can imagine, maybe you want to filter on whatever model it is, what date these completions were sent. Maybe you want to filter from a few days ago. Maybe there's a bunch of different metadata tags you've added. This is how you can filter on that. Maybe you want to check on tool calls versus not tool calls and distill models like that. Or if you just want to do a simple string search based on the input or output. So those are all the ways you can filter output. And then also, if you want to just click on a single completion, you can filter like this to see all the ones that have the metadata tag as myself. And then at the top right, you'll see 2 options here, evaluations and distillation. So let's just quickly go into the evaluation. So this is the evaluation platform. You can first see that you have a name of your evaluation. So let's just call this testing. And then you'll have the metadata or the file that you've uploaded. So this is the JSON-L from the completions. And then these are responses. So you can create responses of different runs if you want to. So let's actually use 4.0 mini as well across this data and then play around with temperature. And now we can run 2 separate instances of this. And then this is the testing criteria we touched on where there's 9 different ones. The ones I'll call out is the custom prompt. So this is where you can choose a grader. So let's just choose 4.0. And then this is where you would put in your LLM prompt. So can you make sure the answer is correct? And then you can add grades here. So please respond yes or no. And then yes, maybe would pass, and then no would fail. And then this is how you would add a grader. There's a few other graders here. So there's a few deterministic ones, so like valid JSON, a string check matches a certain schema, and then there's some semantic similarity, sentiment analysis, and text quality as well. And then one other one to call out here is the factuality one. So if you do have a RAG use case, one thing you could do is have a grader, your question, which is your input, your model output, which is the output text, and then a reference. So maybe you upload some sort of file reference. This is where you could do that. And then you can have passing grades here as well. So these are the different testing criteria we have at the moment. And then finally, as I touched on, you can choose to share your evaluation runs for free if you choose to do so. And then the other option you have here is distillation. So this is where if the selected traces you have, you can then upload the file and then choose to fine-tune your model. Awesome. So this is a quick walkthrough of the platform. Let's now go into the demo. So today's prompt is going to be travel themed throughout. So the first problem we're trying to solve for is generating trip itineraries is pretty expensive and slow at scale. So let's use distillation to cut the latency and cost. And this is something that folks have mentioned to us is pretty important when talking about distillation is cutting costs. So hopefully we'll be able to show that today here. Cool. So first I'm going to walk through the flow of distillation in our product and one way you could go about using distillation, the product suite. So the first thing you'll do is you'll have some traffic that you have in 4.0 or 0.1, and you'll sample that traffic. And then those will go into the stored completions. Then we'll evaluate the completions on some set of qualitative criteria to judge the best itinerary according to the user's question. After that, we'll run a few different experiments, testing the model against different parameters and prompts to find which one has the best qualitative response. And then finally, we'll take those evaluations and choose like which one is the best, and then use those completions to distill into 4.0 mini. And then once that's done, we should also evaluate again to check if 4.0 mini's fine-tuned responses are just as good or at a level that we're okay with from evaluations. And then we'd continuously repeat this cycle. Great. So let's hop into the demo. This code has been shared already in our build our repo. So if you want to follow along, feel free to just fork this demo. So just to give a high-level walkthrough of what's happening here. In this demo, we're basically creating trip itineraries with different models and prompts. And then we'll take the best models, the best results from a certain model, and distill them into 4.0 mini. So the prompt here is we're basically just creating a customized travel itinerary for a given destination. And then we're going to provide a destination, a number of days for the trip, and then here's some steps we want to follow, and then certain notes that we care about. One thing to mention here, and I've done this throughout the demo, is I've actually used our generate anything in our playground to create most of these prompts and iterate from there. So if you aren't already using that, it's a great way to start using prompts pretty quickly. And then finally, we created a training and test set. You can think of the train set as the completions that are coming in that you'd want to evaluate against, and then the test set is live traffic that you want to see if the distilled model does well against. Cool. And now we're just going to run a bunch of different experiments on the train set. So for example, we're going to run 4.0 on the train set. We're going to run 0.1 preview on the train set. And then we're also going to run 4.0 mini, just to see how all of them perform. So after running this, we can go to the chat completion section. We can filter project, itinerary. Let's filter for the 4th run, apply this, and then we have a few different things come up. to actually just choose the O1 preview results. And then from here, we can start evaluating. So once we have the O1 results, we can add test criteria as we want. I've already went ahead and done this, as it takes a little bit of time for evaluations to run. So if we go to the train set here, we see I have a few different things that have already been run. The first is, right here is O1 preview. This is 4.0 with a higher temperature. This is 4.0 with a lower temperature, and then this is 4.0 mini. And then quickly to walk through what evaluations I chose to do for this. The first was a criteria match. So it was very simple. How well does this adhere to the criteria that the user wanted? And what does this mean? If we go into a certain input here, we can check that the user is asking for, like, I want to check historical landmarks, museums, and theater shows. So that's what the criteria match is looking for. The first custom prompt is just checking to give a final rating based on these categories. So the flow efficiency, variety, pacing, and repetition. And then the second custom prompt is asking for comprehensiveness, creativity, and unique characteristics of the experience. So these are the evaluations we chose. All of them are pretty qualitative because the data set is, the data that the responses the model is giving are pretty varied. So we want to have some way of judging this to a degree. So if we go back to the train set, we see that O1 seems to perform the best across the board. So one thing we can do is just take a look at the data and see where everything fails and doesn't fail across here. So right here, we have 4.0 mini. Right here, we have 4.0. Right here, we have 4.0 with a higher temperature. And then finally, this is the O1 preview responses. And it looks like O1 preview did the best. So the next thing we do, if we go back to the code section, is we'll try to run this on the train set. So the first thing is we want to distill the outputs of O1 preview really quickly. So if we go to the chat completions, let's add these metadata tags again. Project, itinerary, run, 4. If you apply these, choose O1 preview, and then distill, we can choose a model. So let's choose 4.0 mini, and then add any suffix we want. So testing itinerary. I won't run this as I've already gone ahead and run this. So if we go to our fine-tuning jobs, we can see the itinerary here, and we see a training loss that's pretty decent. So now the next thing, as we saw in our distillation flow, is now we've distilled our outputs. Now let's see if we can evaluate these outputs again. So I went ahead and run these on the test set already. So this is the test set results without our distilled model. And we see that the custom prompt trips up a lot of 4.0 and 4.0 mini, but O1 preview does really well. Now let's see our evaluations for our fine-tuned model. We see that the custom prompt 2 here, so it's a lot better compared to 4.0 mini and 4.0. There's a little drop here in the first custom prompt. But yeah, so overall we can see there's some improvements, but some losses as well. So definitely something to look into. And then worth calling out here, since we did distill on O1 preview, there's a little bit of trickiness as we don't have a system message, but that is coming soon. Cool. And then the final thing to touch on here is what most folks are interested in is how do we actually save costs and calculate the latency savings. So in this sample code here, we added some code to just understand for you how to calculate the latency differences between the models. The fine-tuned models perform slightly faster than 4.0 models, but it can vary on the time of day. And then for the cost differences, this is the big gains here. We can expect like a 1/8 reduction in price while getting outputs from O1 to improve 4.0 mini. And that's pretty massive. So the inference for 4.0 is $2.5 for 1 million input tokens and $10 for 1 million output tokens, while 4.0 mini fine-tuned is 30 cents for 1 million input tokens and $1.20 for 1 million output tokens. So the results you can get from fine-tuning off of much larger models while improving on certain benchmarks is something to keep in track of. Awesome. The next demo we have here is going to go through task-specific models. So this one is also going to be travel themed. This one, imagine you're a plane company and you have someone who has a flight and they want to change anything, triage it effectively. So this is just a customer service system that takes inquiries and understands the prompts to accurately triage, resolve, and get the costs quickly down. So the goal here is to distill models within this pipeline to cut costs while maintaining the quality. So yeah, this is a typical like customer support flow, maybe a bit simplified, that we see across our developer base. So the typical flow goes, a user asks a question, and then the question is triaged. So the triager is some sort of classification step. And then it goes to some different set of sub-agents. So you can expect like maybe a booking, a cancellation, an added flight, a status of the flight, or a status of your baggage, and then escalation. And then each of those sub-agents might have their own set of tools and prompts associated with them. The other thing that's also running is a set of guardrails in parallel. So this you can think of as a question comes in, we have to check if the questions are accurate or not accurate and make sure we can make correct decisions based on that. Cool. So we're going to walk through how you should think about choosing what parts of a system you should use distillation for and what parts you might not want to. So in this, we're going to be distilling the triage agent, the guardrails, and then one of the sub-agents, the status in the system. And yeah, as I mentioned, it's important to note that like for every system, there can be parts that can be distilled while others need to rely on higher intelligence models. And that's also where evals come into play on making that decision. So if you have robust evals, you can make the decision of, hey, maybe I can make this decision of having a smaller model take this job. And then there's also a few different decision matrices you might want to think through of when to distill versus when not to distill, like how hard the task is. If it's very simple, like a triage where you're just classifying information, it might be very easy to do distillation there. Versus if you need like long form output that's super creative, maybe 4.0 is still the right model for you to use. Great. So let's hop into a demo of how this works. So we're going to go through the 3 different agents and then how we've made decisions on the distillation process. So the first is a classifier agent. So as we saw in the diagram, the triager, his job is to choose whether to go to the booking, the cancellation, editing flights, the status, or escalating to a human. So we define those criteria. We've added steps to how to think through the question, and then added some few shot examples to go through the prompt. Like in previous examples, we've added a few different test and train sets. Minimize that. And then now we're just going to run the classifier on 4.0. So as you see here, we're just going to add our metadata tags, store completions, and then have a response format JSON object. And then I made this multi-threaded just to run it a bit faster. So actually run this 12 and then run execution. And then one thing to call out that I didn't mention yet is it's pretty important to have good metadata tagging when you're using our distillation product, because then you can easily organize the traces that you're sending. So you can think of a good way to organize this as maybe at a project level inside of the dashboard, you might have certain projects associated with different things. So then that's one way of filtering at a higher level. And then in a project level, the metadata tagging will help you versus like any changes you make. So any diffs, maybe that's one that you want to add as a metadata tag. Maybe like the model you're using or the parameters you're using as well. So we quickly ran all of these, and now we can check the results of this. So if I go back to our completions, I can see that I get run 12. The stage is the classifier step. So in this multi-agent setup, I'm particularly looking just at the classifier, and then I choose the model that I want to look at as well. And we get 100 completions here. And now we can evaluate if we need to. And then we can run a few evaluations. This has already been done. So let's go to the evaluations for the classifier. And we see we ran this for 4.0 and 4.0 mini. It looks like 4.0 has a bit of a higher classification result. So we can go back to our evaluations here. And then the format you would go through is once you filter on all of these, you can choose to distill, choose the base model you want to use, so 4.0 mini, and then run the evaluation. So we call this the classifier, and then run the evaluation. We've already went ahead and done that as well. And then we can see the results on the test set where we see 4.0 mini with the fine tuning run a bit better than 4.0 mini normally, and then a little worse than 4.0. And that's like a pretty good result where we have a bump in accuracy, but we also get to save cost. So if your threshold for maybe releasing this to customers is if the classification was 95% correct, this let us do that. Great. Now we can check the status agent. So one thing to note here is there's probably steps in a multi-agent orchestration system where you have some sort of sub-agent that has tools that it can access to, but also sometimes it doesn't have all the necessary information to do a tool call correctly. So this is going to be a way for us to have good distillation practices on like when we should improve our models for tool calls. So just to quickly go through this prompt, we have a couple of tools here, the check-in tool and the baggage tool, a few different instructions based on the user's question, and then the tools we have here. And then again, just a few example prompts, and then a test set. So if we go and run these results again, we go to the status agent. This is on the test set, so we've already went ahead and run all of this. We see that we have 4.0 mini, the fine-tuned model, and then 4.0, the normal. And we see that 4.0 does not as great as 4.0 mini when it's fine-tuned. Maybe this won't always be the case, but it's definitely something where it's an unexpected win if you do get better performance out of a smaller model that's fine-tuned. Great. And then the final example to talk through is guardrails. So how you should think about guardrails generally is you have a user question that comes in. So maybe the user's like, what do I need for a beach vacation? As we mentioned, in parallel, you're probably going to be looking for the right information that's needed. So what are all the possible items that's needed? A list of these items. Run a search, and then run a prompt to get the answers back to the user. In parallel, you probably want to check, is the request a good or bad request? So some criteria you might check for is like hallucination, inappropriate content, prompt injection. And then if the request is not bad, you would do nothing. If the request is bad, you would want to show an error to the user. This is a typical guardrails flow that we see. And usually this process is pretty good for distillation because the decision matrix is pretty easy. It's a binary yes or no, depending on very clear and set criteria that you're trying to set, which is good for a model like 4.0 mini, as long as the performance is solid. So let's look at the prompt we're using here. The guardrail prompt is pretty simple. We want to handle inquiries only related to the airline service, and then before responding, check if it's within any of these categories. So these are the categories we have: flight booking, cancellation, edit, status, and then escalate. And then we have two different responses that were allowed: an approved response or a response is like, hey, this is only for airlines related to these categories. Please check if this matters. So again, we're going to run for on the sample prompts. So this is our training set. Let's quickly run this. And I don't think I ran here. Cool. Now, as this is running, we can see the results come in. So if we check our guardrails training set, you see that 4.0 does pretty well for guardrails, but 4.0 mini doesn't. And then one thing we haven't done a ton of yet is actually just looking at the data. This helps a lot in understanding like where a model might be incorrect. So we can see that, hey, system messages here, and then the user messages, how do I manage my booking? But the response is, I'm only here to assist with certain things. But we see that 4.0 does a much better job at actually approving this. And we see a few different instances of that across the system. What's the flight cancellation policy? That should be something you can help with because it says it can only help with cancellations, but it looks like 4.0 mini isn't respecting that. There's obviously maybe some prompt engineering things we can do, but a quick thing is, hey, after looking at the data, maybe the first step we can do is prompt engineering. And if that doesn't work, maybe we can run to distillation. So here we can run a fine-tuning job on the guardrail. And then once it's run, we can go back here to our test set and see the performance changes. So we see that 4.0 gets like an 88%, 4.0 mini gets an 83%, and then our fine-tuned model gets a 92%. So yeah, that covers a few different topics on how to think through how you choose different parts of a multi-agent system to evaluate, and then also how you would improve the models accordingly. Great. So now going forward, we're going to look into a few different things. One, we're going to look into customers who are actually using our distillation product today. Then from there, we're going to walk through a few different flows that we might not have talked about and are coming on the pipeline. And then finally, we'll open it up to any questions down the line. Great. So many developers are already using distillation platform today. One customer that is distilling models is Superhuman. Superhuman is an email client that provides a super snappy experience to users and has AI powering their auto completions and email writing all over the platform. One of the main reasons Superhuman uses distillation is to get both latency and cost wins, which you can do with smaller models. So as workflows can become more complex, it's always important to remember that distillation offers a lever to make experiences snappier and cheaper. Great. And now we'll go through a few different best practices on how to think through distillation and the product suite. So the first is just organizing completions. I touched on this briefly, but staying organized through projects and tagging makes it easy to actually create data sets that are important to then run fine-tune jobs. And the most important thing is having those data sets curated in a way that's easy to manage. So by staying organized, it helps you not only make better models for your business, but also makes it easier for other developers who are using the platform as well to understand the work you're doing. The next is consistently evaluate. We'll say this over and over across many build hours, but evaluations are the key to every decision you make in the product that you're building. Without it, you're left in the dark. So make sure to consistently evaluate and make sure to build that flywheel so that anytime you do make a change, you can test if it works in our evaluations platform. And then when you are evaluating, remember to compare and experiment. Continue to compare against results. Like maybe you want to change prompts. Maybe you want to change the temperature or other parameters. Maybe you want to use a totally different model. That's where you want to continue experimenting and comparing results. And
mentioned this a couple times already, but data. Data set curation is a journey, and creating good data sets, even for small fine-tuning runs, makes a pretty big difference. So it's pretty important that we can curate data super easily and effectively for users. And then understand when to distill models and when not to. So not every part of a system should be distilled. So knowing when things need to be distilled is super important for users. And some things to think through here is maybe a matrix of like how you can think of, for example, like classification is super concrete. You know what needs to be done, and then you know it's like super specific as well. There's only a few right answers, and that's probably a great place to distill, versus maybe a trip itinerary is not the top place to do model distillation, but for certain cases it might be. So having that clarity of when to distill and when not to. Another example is maybe if you're working through building a coding agent, maybe you don't want to do distillation for finding a really hard bug in a minute part of the code base. It's probably better for a large model like O1 to look through. Great. And then some other flows that might be coming down the pipeline that we're excited about offering is filtering and annotating evaluations into distilled models. So you can think of a scenario where you want to store completions, and then you'd want to run evaluations on those completions like we've been doing. But right now, as you saw in our demos, once you ran those evaluations, you just choose the outputs of those, the best evaluation to then distill your model. But maybe you want to annotate those incorrect completions, or maybe you want to filter on only evaluations that passed. And then you can curate a data set that matches the needs of your business, and then distill that model. So this is a flow that we're excited about offering to our customers as well. Great. And then the final thing to touch on here is continuous evaluations. So you can imagine a world where you sample some percentage of your traffic continuously. So let's say you have these online evaluations where 20% of your traffic is sampled, and then you run evaluations on those continuously. And then sometimes you get results back. Sometimes those results you can just quickly iterate on prompts to improve the model performance, and then run evaluations based on those prompts. The other is you can run those evaluations on that traffic and then take those good results and then fine-tune the model even further. And then you have this continuous loop of an improving system where you sample your traffic maybe every day, run evaluations on that traffic, and then take those good results and keep fine-tuning. Great. Now, with the last bit of time we have left, let's hop into a Q&A.
Awesome. Yeah, we had a number of interesting questions come through the chat. So thanks, everyone, for participating. Let's start off with just the purpose of fine-tuning and how to think about it. We had a couple of questions along that line, specifically around like how should you curate training data, and what should the focus of the curation be? Like, should it focus more on facts, or should it focus more on like the style of the responses or model behavior?
Yeah, so the focus should be more on the model. So the specific tasks are like, you should focus on like the specific tasks that are most important to you. I think the things to mention here is when you're curating training data, make the distribution of data something similar to what you would see in production. A lot of times people, let's go back to the customer support scenario. A lot of times people only include the happy path of data for data set curation. And then once they do that, they fine tune and they realize out of distribution questions to the model get really bad answers. So make sure you have a good distribution. Like, not everyone asks cookie cutter questions all the time. So making sure you have those non-cookie cutter questions also in your training set distribution is important.
And it's not a way to add knowledge to the model, right? It's more
No. Yes, it's more about formatting tone and style of how the model behaves based on the examples it sees.
An interesting question on that line was around using the same model to fine-tune itself, like data from the same model to fine-tune itself. someone asked if it's possible to use 4.0 to fine-tune Distill 4.0 on specific tasks.
Yeah, I'd say distillation is useful for improving student model responses. So like distilling from 01 to 4.0 can make sense. But going 4.0 to 4.0 is less likely to be helpful because the range of answers is already within what the model knows in its like knowledge corpus. So it's not going to greatly improve performance if you distill 4.0 on 4.0. Maybe what's more important is having a data set that is unique that will help 4.0 models improve. And that's not necessarily going to come from 4.0 model responses, but rather like human responses or like data sets that you annotate or curate yourself.
And then in terms of best practices for identifying which parts of your architecture are potentially good candidates for distillation. I know you touched on this a little bit in the best practices section, but wondering if we can go deeper on that. Like, how do you actually break down your use case to identify areas where distillation might provide gains in performance?
Yeah. So I'd say the way to think about this is you probably have a matrix of like how general a task is and how much precision you basically need. So you can think of the best case scenario is a super narrow task with low precision is something that distillation would be useful for. So something like sentiment analysis, entity extraction, etc. And then some other tasks might fall into the spectrum of maybe less general, low precision, or like narrow and high precision. And those might be good for distillation as well. And some examples of that could be like copywriting, summary generation. So those are like certain tasks where are like best practices on areas to identify like some places where distillation would be helpful. I think something to touch on is like, it's probably not good for like very general tasks that also are high precision. That's where like very smart models are probably a better bet than choosing a small model with less like world knowledge or less understanding of the nuances that are needed to make strong decisions for your business.
And in terms of choosing evaluation metrics, and maybe let's switch a little bit to the evaluations portion of distillation, because we have a few questions over there. How do we choose accurate eval metrics, especially if the model evaluating is the same as the model generating answers?
Yeah.
Wouldn't there be some risk of, maybe not having the right data and distribution there?
Yeah. So a high level thing is models are generally just better at evaluating than creating. Maybe just to give like a concrete example of us, like as humans, it's probably easier for me to tell which poem is better comparing to than asking me to create a poem myself. And models are very similar that way. Like they're probably much better at discriminating against two different poems than choosing a poem that one person likes, that choosing a poem to create. It's like one way to think about this is like, how would you describe evaluation is like model generated answers are tricky to evaluate, but having clear criteria. Like another thing to mention here is you could use like 4.0 to evaluate 4.0 responses, but the prompt for the 4.0 evaluation should be super specific to the task you're trying to do. Like it might even be good that you can use a 4.0 mini to evaluate 4.0 responses, as long as the task is super specific, that a model can make the right decision most of the time. And then another thing to mention here that we see like good results of is you should always think to models as evaluators is always a tricky thing. So like having a string check is always nice, but there's always going to be decisions where you want a model to choose because it's going to be a nuanced decision. And if there are decisions where you're using LLM as a judge, having some sort of human similarity with the model choice. So like if you have 100 examples, have a human look at those 100 examples and grade them, and then look at what the model does. If they differ a lot, then you probably have to change your model prompt to make sure that the prompt matches how close you are to human preference. So that's another thing to keep an eye on.
And then a couple of folks are also curious about grading strategies. when should you use an OpenAI provided grader versus a human grader versus, I know this is something we're working on, custom grading. So I'm curious how you'd advise folks to think about grading.
Yeah, so there's a few different parts of grading or evaluating responses, right? There's deterministic evals. You should always have those. As much as possible, like deterministic evals are good, but as I mentioned, like there's always going to be a case where you can't always have deterministic evals. So having that split of maybe having a model grader do certain tasks is going to be pretty important to the use case you're sort of building. Yeah, did that fully answer the question?
Yeah, and I'm sure once we have custom grading, we'll be able to speak to that a little bit more.
Yes. Yeah.
We did have one interesting question actually come in as a follow-up to when we were talking about the role of fine-tuning. It's specifically around if fine-tuning is mostly for tone and style and not adding know-how, why does it work on classification tasks, right? Because you're not really like imbuing knowledge into the model, but how does fine-tuning improve the model's ability to classify based on certain criteria?
Yeah. So distillation and fine-tuning in general, like often helps the model focus on various aspects of the input. So like learning how certain words or phrases correlate to the correct classification task you're choosing. So it's not adding more knowledge, but it's improving pattern recognition to a degree that it can do a much better job at picking up the nuances of a certain task pretty quickly. And classification is one that it does pretty well on. And I think the one thing to call out here is you can overfit sometimes doing classification. So that is something to keep an eye on when you are distilling and fine-tuning models for classification, if you do see out of distribution questions that come in.
And then kind of related to that also is around sort of distillation on tasks that require high text quality and maybe grounding the model in knowledge using RAG. We didn't really cover those examples, but how would you advise folks to think about situations where it's also about the quality and the sort of tone of the model response, but also like the factuality of it?
Yeah. So when you're doing distillation where you have like outside responses or like RAG adding in context learning to the equation, I think the first thing to do is actually like taking a couple steps back and just evaluating how good your RAG system is at doing the retrieval in the first place. Once you are like confident in that, then the data itself is going to be good. And that's the most important thing, is like having a good data set to distill models from. So if you can like work backwards from setting up good evals and like having like a really robust way to actually do the retrieval step, that will help in going forward of making distillation much easier to do.
Awesome. I think that's all the time we have today for this build hour. Thanks everyone for your participation. We will follow up with all of this content, the recording, the code repo in case you missed it, and excited to see you for future build hours. But otherwise, thank you from us here at OpenAI for attending.
Awesome. Thanks everyone.